Students, welcome back to my channel. So today we'll solve this example regarding the Jacobian, which is asked in the January 2026 VTU examination. So the question is that here we are given three functions, that is u, v, w, which are functions of x, y, z. So u value is yz divided by x, v is equals to z into x divided by y, and w is equals to xy divided by z. So the question is that we have to find the Jacobian. So this is what the Jacobian is, that is del of uvw divided by del of xyz. This means we have to find the Jacobian of uvw with respect to xyz. So see the solution. So write the given first. So that is given u is equals to yz divided by x, v is equals to zx divided by y, w is equals to xy divided by z. So this is what the given to you. So now the term which we need to find, so that is equals to the Jacobian is, so that is defined by, that is del of uvw divided by del of xy z is equals to, so the definition of this Jacobian is given by, so we have to take the determinant, that is determinant like this. So determinant, that is a 3 cross 3 determinant. So we are three functions here, that is uvw with respect to xyz. So therefore we have to take a 3 cross 3 determinant. So the inputs in the 3 cross 3 determinant are given by, in the first row we have to write the del u by del x, del u by del y, del u by del z. So in the first row we have to write the partial derivatives of u with respect to xyz. So in the second row we have to take the partial derivatives of v with respect to x, y, z, that is del v by del z. Similarly in the third row we have to take the partial derivative of w with respect to x, y, z, that is del w by del x, del w by del y, del w by del z. Is it clear, students? So now see, so we have to find all these 9 entries. So we have to find the values of all these 9 entries. So how to find them? So see here, so we have u is equals to yz divided by x. So we have u is equals to yz divided by x. Now using this value, that is u is equals to yz divided by x, we have to find the first row entries. So that is del u by del x, del u by del y, del u by del z. So now del u by del x is equals to del by del x of yz divided by x. Means we have to take the partial derivative of u, that is yz divided by x, with respect to x here. Is it clear? Now, so here we are differentiating this function with respect to x, means so the whatever the variables which are not in x, so we have to take them as constant. So that is y and z are constants here. So just you have to differentiate 1 divided by x, because 1 by x we have. So take y and z outside. So we have to differentiate 1 by x only, that is with respect to x. So that is del u by del x is equals to y into z. So we know that what is derivative of 1 by x is minus 1 divided by x squared. So that is minus yz divided by x squared. Is it clear? So this is what the value of del u by del x is. So similarly del u by del y, that is del by del y of yz divided by x. So here we are differentiating this one with respect to y, means so take z by x outside. So we are left with del by del y of y. So that is del by z by x into y with respect to y derivative is 1. So therefore z by x, that is z by x into 1, that is z by x only. So therefore del u by del y is equals to z by x. So this is what the value of del u by del y is. So now similarly del u by del z, so that is equals to del by del z of what is u value yz divided by x, that is equals to, here y by x is constant because we are differentiating this term with respect to z, means so we have to take y by x constant. So that is del by del z of z only. So that is again 1, y by x into del by del z of z is 1. So therefore del u by del z is equals to y by x. So these are the, so that is 1. So this one is 1. Del u by del x is equals to minus yz by x square, del u by del y is equal to z by x, and del u by del z is equals to y by x. So these are the first row entries. So similarly v is equals to what we have, v is equals to z x divided by y, that is xz divided by y. What is that is the value of v. So we have to find the second entries now. So that is del v by del x. So how to find the del v by del x? Del by del x of what is value of v, x z divided by y, that is equals to, here we are differentiating this term with respect to x means, so take z by y outside, that is only differentiate x term. So partially differentiating x term, so derivative of x with respect to x is 1, so therefore z by y. So therefore del v by del y is equals to 1, sorry, del v by del x, that is equals to 1. So now similarly del v by del y, that is equals to del by del y of x z divided by y. Again x into z is constant here because we are differentiating this term with respect to y means x into z is constant, take it outside. So only differentiate y term, that is del by del y of 1 by y x into z or z into x. 1 by y derivative is again minus 1 divided by y square. Is it clear? So now multiply the minus sign. So that is, so finally del v by del y value is minus x z divided by y square. So this is what the value of del v by del y is. So similarly del v by del z. So that is del by del z of v value is again x z divided by y. That is equals to, again here we have to take x divided by y as constant because we are differentiating this term with respect to only z, that is partially with respect to z means x by y is constant, so therefore keep it outside. So only differentiate z, that is x by y del by del z of z only. So what is derivative of z with respect to z is, that is 1, that is equals to x by y. So therefore del v by del z is equals to x divided by y. So now last rows. So now we have to find the entries of last row, that is w is equals to, what is w is equals to? W is equals to, we have xy divided by z. W is equals to, we have xy divided by x, z. So now find the del w by del x, that is equals to del by del x of what is the value of w, xy divided by z. Now here differentiating this term with respect to x partially means y by z, y divided by z, that should be kept constant, that is del by del x of x. Is it clear? So y divided by z into 1, that is equals to y by z. So therefore del w by del x is equals to y by z. This is what the value of del w by. Now similarly del w by del y, so that is equals to del by del y of what is value of w is equals to xy divided by z. So we are differentiating this term partially with respect to y means x and z, those should be kept constant, so therefore take them outside, that is x by z is constant, del by del y of y only. So that is x by z into del by del y of y is 1, so therefore derivative of y is with respect to y is 1, so therefore x by z. So therefore del w by del y is equals to x divided by z. Is it clear, students? So next last entry is del w by del z. So that is del by del z of what is w value again, xy divided by z. So w value is xy divided by z. Here we are differentiating partially with respect to z means x into y is constant, so take the x into y term outside. So we are left with only del by del z of 1 divided by z. Again x into y, what is derivative of 1 by z is minus 1 divided by z square, minus 1 divided by z square. So therefore del w by del z is equals to minus xy divided by z square. So this is what the value of del w by del z. Now so consider, so what we have to find here, we have to find the Jacobian of uvw divided by xyz. So that is Jacobian of uvw with respect to xyz. So we have to find the Jacobian. So what is the definition of Jacobian? Again substitute the values. So what is definition of Jacobian? So in the first row we have to write the partial derivatives of u with respect to xyz. So that is del u by del x, del u by del y, del u by del z. So that is what the first row is. So similarly in the second row we have to write the partial derivatives of v with respect to xyz, that is del v by del x, del v by del y, del v by del z. So similarly in the third row we have to write the partial derivatives of w with respect to xyz, del w by del x, del w by del y, del w by del z. Is it clear, student? Now substitute the values, respective values. So now see, what is the value of del u by del x we got? The del u by del x value is minus yz divided by x square. Is it clear? Del u by del x is minus yz divided by x square. So del u by del y is z by x. And similarly del u by del z value is y by x. So this is what the value of del u by del z. So similarly substitute the second row entries. Del v by del x value is, what is del u v by del x value? So that is it given by, so z by, so what is the value of del v by del x is, del v by del x is, so this one is, so z by y, I'm sorry, it was 1, so that is, I'm sorry, that is z by y. So substitute that, z by y is equals to, so that is del v by del x is equal to z by y. So similarly, what is the value of del v by del y? So that is x into z divided by y square. You can see the value. So del v by del z value, so that is given by x divided by y. Is it clear? So complete the determinant. So similarly in the third row, write the del w by del x value. So what is del w divided by del x value? See the value here. What is the value of del w by del x? That is y by z. Y by z. So similarly in the second entry, we have to write the del w by del y. So del w by del y value is x divided by z. So that is x by z. So here in the last entry, we have to write the del w by del z value. So that is minus xy divided by z square. So now we substituted all the values of the partial derivatives. So now we have to expand this determinant. So don't directly expand this determinant. So because the calculation becomes difficult. So the calculation becomes more complex. To avoid that, so take 1 by x common from the first row. 1 by x common from the first row. Similarly 1 by y common from the second row and 1 by z common from the third row. So you can directly expand this determinant along first row or first column. So the answer is same, but the problem is that the calculation becomes more complex. So to avoid that, so take 1 by x common from first row, 1 by y common from second row, 1 by z common from third row. Is it clear? Now write the remaining values. So if you take 1 by x common from first row, what you are left with here? Y is minus yz divided by x. So here z, here y only. Similarly in the second row, if you take 1 by y common, so z in the second entry we have to write minus xz divided by y. So in the third row we have only x. Similarly from the third row, if you take 1 by z common, so you are left with y, here x, here minus xy divided by z. So this is what the remaining determinant entries are. Is it clear? Now expand this determinant. So expand along first row or first column. You can expand along any row or any column. So we have del of u v w del of x y z, that is Jacobian is equals to what we take the common 1 by x y z. So what we are left with, that is minus xy z y or y z divided by x. So z by x, here also, here it is z. So let me confirm the values. So minus yz by x, z y. So that is z y first row. So similarly the second row is, what are the second row entries? Z minus x, z divided by y. So then x. So similarly y, x, and last entry is minus xy divided by z. So now we have this determinant. So expand along first row now. X, y, z as it is. So to expand this determinant along first row, keep this element as it is, minus zy divided by x. So in the bracket, so if you are expanding this determinant along first row, so here write this element, that is first element, here write that element. So if you are expanding along first row means, so skip the first column and first row, skip them. So what we are left with, so this element and this element minus this into this. So that is into minus xz divided by y into minus xy divided by z minus x square. This into this is x square. So similarly So here one more bracket I will apply minus. So next this one minus z. So the determinant, whenever you are expanding a 3 cross 3 determinant, the sign convention should be plus minus plus. This is what the sign convention is. So now you have to take z as minus z. So again, so z element is present in the first row, second column. So skip the first row, second column. So what we are left with, z into this value. So z into minus xy divided by z minus this into this value minus x into y. Similarly, last element plus y into. So skip the first row, third column. So what we are left with, z into x minus xz divided by y. Is it clear? So this is what the complete determinant values. Now just we have to simplify this one. So 1 divided by xyz as it is. So multiply this minus zy divided by x. So here y and y can get cancelled, z get cancelled. So minus into minus is plus. So therefore x into x is x square minus x square. So complete the bracket. So now see this term, z and z cancel, minus z outside minus xy minus xy. Is it clear? So now come to third term plus y. So here z into x or xz as it is, minus into minus becomes plus. So here this one is plus, then so here here there is a y minus y, because if you multiply z into x, zx minus of y into minus xz divided by y. So there is a y here, and this y get cancelled. So you are left with plus zx or xz. So now just simplify this one, 1 by xyz, 1 by xyz. So this one is get cancelled. So this complete is 0 minus z minus 2xy. So now see, this one is zx plus zx, that is 2zx plus 2zx into y means 2xyz. So again simplify this, 1 divided by xyz. So 2xyz, this minus becomes plus, 2xyz plus 2xyz. So that is 1 divided by xyz, 2xyz plus 2xyz, that is 4xyz. So xyz get cancelled. So the value is 4. So therefore what we have to find, del of uv w divided by del of xyz, that is equals to 4 is the required answer.